In this video, I would like to provide you with an introduction to angle laws. So without further ado, let's begin the video. Now, I find it useful to first cover some definitions first relating to angle laws before we really dive into what angle laws are themselves. So one important definition to keep in mind is the line segment, which is defined as the following. So a line segment is just a part of a line that has two endpoints and a definite length. So if we have a point A over here, then a point B over here, this here would be a line segment since it has a definite length. It's defined between points A and B, that's its length, and it's a line. In contrast, a ray is similar to a line segment. However, one end extends to infinity, and as such, its definition is the following. So a ray has only one endpoint. The other end extends to infinity, and it would be drawn as the following. So starting with our point A, and this goes on to infinity. Now we could denote this by drawing an arrow like so. Of course, I'm not actually going to draw to infinity because that would take a very long time, or more accurately, an infinite amount of time. Another definition that we should be familiar with is the line. A line is kind of like two rays put together. So a line has no endpoints and it's infinite in length. So it's like two of these rays here. So you're not going to have a point A or point B. You're just going to have two arrows. Like so. And of course, this line will continue on this way and the other way for infinity, but we didn't exactly want to draw an infinitely long line or an infinitely long horizontal bar to represent the line, since that would take an infinite amount of time. So now we know about line segments, rays, and lines themselves. We can move on to angles. So let's define angles. So there are three main types of angles. And the three types of angles are acute angles, obtuse angles, put that on the right side, and finally, right angles. So acute angles look like the following. We have two rays. Let's draw some straighter rays. So you have two rays. Let's say that come from a point O. So this over here is our point O. And the acute angle is the angle between those rays. So I'm first going to kind of draw the images of these angles, so you can get an intuitive understanding of how you may find them in some math problems. And then I'll give you some formal definitions of these angles themselves. And this symbol that I'm drawing here and here is theta, and it just represents an angle. So this is kind of how the different angles look. And a more formal definition of these angles is the following. So for an acute angle, it can be defined as an angle between 0 and 90 degrees. An obtuse angle can be defined as an angle between 90 and 180 degrees. And then a right angle would be a 90-degree angle. Hence the 90 degrees written inside the angle. Now, more mathematically, we can write this as theta for acute angles must be greater than 0 and less than 90 degrees. And then for right angles, theta is equal to 90 degrees. So that means we can also replace the 90 degrees with theta and define theta with this over here. And for obtuse angles, as you can probably already guess, we can write the quality as 90 degrees is less than theta, which is less than 180 degrees. If theta was equal to 180 degrees, and this would be our point O here. So for these diagrams, our point O's are here and here. If we had a 180 degree angle, it would look like this. And these two rays essentially just make a line. And this is called a straight angle. I didn't include it as one of the main angles, since although it is technically an angle, it is typically not very useful when solving angle problems. So this is like a bonus. So I'm putting a star for bonus. It is also important to note that you may see right angles written in a slightly different way with a rectangle as the angle. This means the exact same thing as 90 degrees. It's just a different way of writing 90 degrees. It's a shorthand version of writing it. Whoops. So now we can move on to the angle laws. Now this video will not go into solving problems with angle laws, but more specifically identify some useful angles which you will encounter, or relations between angles that you will encounter when applying angle laws to problems. The next video on angle laws will deal more with problems involving them. So you may find angles whose relationship is such that they are supplementary. And these angles in this relationship are called supplementary angles. A more formal definition is that supplementary angles are two angles are supplementary if their sum adds up to 180 degrees. So for example, if we have a line we have our point O, and then we have a ray coming from that point O, the angle A and the angle B, when summed, this sum will be equal to 180 degrees. And hence, these angles are supplementary. In contrast, you may find complementary angles, which are when two angles add up to 90 degrees. So two angles are complementary if their sum adds up to 90 degrees. So if, for example, we have a right angle here, and I'm going to be using the shorthand notation, but then we split this right angle like so, and this over here is angle A, and this over here is angle B, since A and B, if summed, add up to 90 degrees, they're complementary. Another important relationship are vertically opposite angles. So these are angles that form opposite to each other. So they are angles that form opposite to each other. Well, the angles that form opposite to each other are called vertically opposite angles. And these vertically opposite angles equal. So the angles that form opposite to each other are called vertically opposite angles, and these vertically opposite angles are equal. So, for example, if we have two lines which cross like so, this here can be point O, and let's name the angles here A, B, C, D. We know that A is going to equal to B, and that C is equal to D. Since, as they're vertically opposite, they're therefore vertically opposite angles. And we know that these vertically opposite angles are equal. Whoops. And this will be an extremely useful property when solving angle laws problems. Another thing which is interesting to note is that since C plus B together form a straight angle, B plus C are supplementary, and A and D are supplementary. And in fact, B and D are supplementary, and A and C are supplementary. And altogether, A plus B plus C plus D must together equal 360 degrees as they go full circle. So this here is another interesting property. So I hope this video was helpful for clarifying some important definitions and establishing them, and providing you with a basic introduction and foundation for angle laws problems. The next video will focus more on the problem solving aspect of angle laws problems. However, it was important that you watch this video first, since the definitions and the basic principles are necessary in order to begin solving the actual problems. So I hope you enjoyed watching the video, and thank you very much.